In this video, I'll show you how to use the chain rule to differentiate composite functions. This equation provides a method for taking the derivative of the composite function f of g. The method is called the chain rule for differentiation. Let's take a look at a couple of important features of the chain rule. Here, f is the name of what is often called the outside function, and g of x is called the argument of the function f. When differentiating a composite function, we need to take the derivative of the outside function, while keeping the argument, g of x in this case, the same. Multiply f prime of g of x by the derivative of g with x as its argument. Now, let's look at some examples using the chain rule. For the first example, let h of x equal sine of 3x squared. Our task is to compute the derivative of h. One of the trickiest aspects is to recognize when you're dealing with a composite function, and then to recognize what the outside function is and what the argument is. This first example isn't too bad. We want to write h of x as a composition of f and g. The outside function, f, is sine of x, and g, the argument, is 3x squared. The next step is to compute the derivatives of the outside function and the argument. Here, the derivative of f is cosine of x, and using the power rule, the derivative of g is 6x. To use the chain rule, we need to take the derivative of the outside function, plug in the argument, and multiply by the derivative of the argument. So the derivative of sine is cosine, plug in the argument, and then multiply by the derivative of the argument. Now let's look at another example. Let q be an exponential function in terms of t. Our task is to evaluate the derivative of q with respect to t. In this example, it's a little trickier to recognize that this is a composition of two functions, to identify the outside function and the argument. So, we need to write q as the composition f of g of t. Here, f, the outside function, is e to the t, and g, the argument, is 1.44 times t. Next, we need to find the derivatives of the outside function and the argument. The derivative of e to the t is just e to the t, and the derivative of 1.44t is just 1.44. Putting this together with the chain rule, we need to take the derivative of the outside function, plug in the argument, and then multiply by the derivative of the argument. Let's look at one more example. Let r be a logarithmic function in terms of x. Let's find r prime of x. As with the other examples, we first need to recognize that r of x is a composite function. So here, f is the outside function. This is log base 3 of x, and g, the argument, is the linear function for x minus 7. Next, we need to compute the derivatives of the outside function and the argument. Here, the derivative of f is 1 over x times 1 over ln of 3, and the derivative of g is 4. To apply the chain rule to compute the derivative of r, we first have to do the derivative of the outside function, and I've left some extra space here because we're going to plug in the argument in place of x. And then we multiply by the derivative of the argument. So now that we have stated the chain rule and we've used it with 3 different composite functions,